Hello everyone. In this video, I'm going to discuss about merge set. Okay. So here now I'm going to discuss about the merge set. Okay. So here, see what is sorting first. Okay. So sorting is nothing but arranging what a list of elements in either ascending order or descending order. That is called sorting. Okay. So by using sorting technique, so we can arrange elements in either ascending order or descending order. Okay. Yeah. Now, how to perform what a merge sort technique on a given list of elements. On given list of elements. Okay. See here. Okay. Here. So this is the what array given as a input. So these are the list of elements given. Okay, in the form of array. So here this is what 0th index, first index, second, third, fourth, fifth, sixth, and seventh. Okay. Now you want to arrange what elements in what either array ascending order or descending order. Okay, these are not in sorted order, right? So now you want to apply which technique? Merge sort technique. So this merge sort technique, okay, follow the divide and conquer procedure. See, divide and conquer. Okay, so conquer. So here, see, in divide and conquer, first we are going to divide array, okay, into what? What smaller parts. Okay, smaller parts. See here how to divide the what array into smaller parts. Okay, see here first this is the array given as an input, right? So it has 8 elements. So here the lower bound means starting index. Starting index is lower bound is 0 and upper bound. Okay. So high is equal to 7. Okay. So now here you need to pick the mid element. Okay. You need to pick the mid element. How to pick the mid element? So here lower bound plus upper bound. Okay. Lower bound plus upper bound by 2. Low plus high by 2 means 0 plus 7 by 2. Okay. 0 plus 7 by 2. Now you will get 3. Why? Because 3.5 means you should omit this for 3.5. Okay. So you here you should take what a 3. So where is 3? Here what a 8. See here this is the mid element. Okay. Now you need to divide. Okay, you need to divide low to low to mid. Okay, low to mid and mid plus 1 to upper bound. Mid plus 1 to upper bound. Like this, you need to divide the what given array. Okay, so here I divided. Okay, so lower bound 0 to mid. What is the mid? 3. And mid plus 1 means 3 plus 1. Fourth index to high. Okay, so this one. Now you need to apply same formula. Okay, so to the what sub arrays also. Okay, so here 0, this is 3. 0 plus 3 by 2. Okay, means 1. Okay, so 0 to 1 and 1 plus 1 to high means here, see, here you are dividing this area. Now you will get 12, 31 and 25, 8. And here 30 to 70, one subarray and 40, 42, one subarray. Next, see, you need to apply the what the same formula to this subarray also. Okay, 12, 31. So here lower bound is 0, upper bound is 1. Here lower bound is 2 and upper bound is 3. And here lower bound is 4 and upper bound is 5. And here lower bound is 6 and upper bound is 7. Okay, so here, okay, apply the formula, same formula. Okay, so now here this is divided into again like this 0, 1, 2, 3, okay, 4, 5, 6, 7. Now see, so this is the lower bound here and this is the upper bound here, right? So now here you need to divide. Okay, you need to what recursively call the divide and conquer method. Okay, for the given array recursively until low is less than high. Okay, so whenever this condition is true, then perform the divide operation. Okay, how to perform the divide operation? First, find out the what mid element. Okay, find out the mid element. Lower bound plus upper bound by 2. Now, after finding the what mid element. Okay, after finding the mid element, divide what lower bound to mid element as one subarray and mid plus 1 to upper bound as one subarray and apply the same formula to the what first subarray and second subarray. Okay, so whenever this condition is true, okay, so whenever lower bound is less than upper bound, okay, perform the divide operation. Okay, perform the divide operation. Now you come to here, right? Now every subarray contains only one element here, right? See here lower bound is 0 and upper bound is also 0. 0, okay, less than 0. Condition is what false. So you can't divide this subarray. Okay, you can't this subarray, all these are what subarrays. Okay, so in order to divide your array like this, okay, so you need to in order to divide what your array into subarrays like this, okay, you require one method. Okay, so that method is merge sort. Okay, merge sort is a method or function, okay, which will divide your array into what possible subarrays. Okay, every subarray should contain only one element at last. Okay, at last. See here, I have written the code. See here, merge sort. Okay, it will take what parameters. What are the parameters? Input array and lower bound and upper. Okay, already I told no. So lower bound plus first you need to find out the middle. Okay, so mid is equal to lower bound plus upper bound height divided by 2. Okay, now after finding the mid element, okay, you need to perform same merge sort technique to the subarrays also. Recursively you need to call merge sort function. Okay, so now lower bound to mid element, lower bound to mid element and call merge sort. Okay, and call merge sort mid plus 1 to upper bound. Mid plus 1 to upper bound means okay. Like this, you need to what recursively perform the what divide operation by using merge sort function. Okay, so up to okay, whenever this condition is true, lower bound is less than upper bound. If okay, lower bound is less than upper bound, then you need to what find out the mid element. Okay, and what recursively call the merge sort method from lower bound to mid and mid plus 1 to 5. Like this, you need to divide. So at last, okay, so whenever this condition is false, means every subarray contains only one element. Then, okay, so you should stop this procedure automatically. Okay, so whenever this condition is false, okay, it won't perform this operation. It won't perform this operation. Okay, after dividing your array, okay, into subarrays, okay, you need to perform the merge operation. Okay, so here merge operation required input array, lower bound, middle mid, and upper. Okay, upper bound. So these are the what input parameters required for the merge function. Okay, so now how merge function works? We'll see. See here, here, see 12 and 31. These are what divided, and 5, so 25, 8. These are divided, right? So here you need to merge these two first, and you need to merge these two, and resultant of these two and these two, you need to merge. Okay, you need to perform merge these. Okay, and perform merge operation of these two, and perform merge operation of these two, and resultant of these two and these two, you need to what merge these two. Okay, at last you need to combine these. Like that, you need to perform what merge operation. So first I am performing merge operation at 12 and 30. Okay, so while performing merge operation, okay, our lowest element will come first. Okay, so 12, 31. Already these are in what sorted order, and 25 and 8. Okay, 25 and 8. Here 8 is the what lowest element. So 8 to 25. Next 32, 70. So among these two, okay, so 17 is the lowest one. So 17 will come first and 32. Next 40, 42. Already these are sorted out. Okay. Now you need to perform merge operation of these two subarrays. Okay. Now for yeah, see 8 will come first and 12, after that 25, after that 30. Next 17, 32, 40, 42. Right. So 17, 32 and 40, 40. Okay, so these are merged. Now you need to perform merge operation on these. Right. So as a human being, we can tell okay easily. So which element will come first? But we are writing a program. We are writing a program. So your computer should what your program should what perform the merge operation of these subarrays. Okay, these subarrays. So here see here this is subarray. Okay, this is subarray from what? From lower bound to mid. This is one subarray and mid plus 1 to upper bound. This is another subarray. Now you are performing merge operation on these two subarrays. So now what I am doing is here I is equal to lower bound I must say. And here I am going to take index. Okay, j is equal to mid plus 1. This is the starting index of j. Okay, mid plus 1 is the starting index of j. Okay, so here j represent second subarray what index, starting index, and here I represent first subarray starting index. Okay, now this I value should not exist. Okay, always I value should be less than or is equal to me, and this I j value okay should be always less than or is equal to upper bound. Okay, upper bound. So this is the what condition, right? Why? Because here I is what representing starting index of the what first subarray, and j in what indicates what starting index of the second subarray. Now first subarray, okay, highest index is what mid position, and the second subarray highest index is what upper bound. So that's why you need to what check these two conditions. Okay, you need to check these two conditions while performing what merge operation. Okay, merge operation. Yeah. Now see here what I am doing is here I am merging these two. Okay, so how to perform okay merging of these two? Okay, why? Because while merging these two, lowest element should come first in the resultant array. So here what I am doing is here okay, so this is array A. This is input array A, and now result resultant array I'm taking as B. Okay, so for B I'm taking K as what starting index. Okay, starting index. Yeah. Now what I'm doing is here K initially I'm giving K is equal to low means 0. Okay, now here B array, B means resultant array. Okay, so now this is at 0th position. Okay, now here what you need to do is here while okay already I told you need to check these two conditions while merging. Okay, I should be less than or is equal to mid and end. J should be less than or is equal to I. Okay. Now what I'm doing is if A of I is less than or is equal to okay B of J. If this condition is true, means first subarray element is less than or equal to the what a second subarray. Then you need to add first subarray sorry A of J, not B of J, A of J. Okay. So here if A of J means first subarray element is less than or is equal to second subarray element, then first subarray element you need to put in the what you need to put in the what resultant array B of J. Okay. Now here A of J, I sorry A of I means I is here. Okay. Here J is here. Okay. A of I. Okay. I is at 0th position and J is at the mid plus 1 means 4th position. Okay. Now A of I 8 and A of J 17. Okay. A of I 4 is less than or is equal to A of J 17. Condition is true. So that's why you need to place first subarray element in the what first first subarray element in the resultant array. So here you need to place what 8 here and increment I value. Why? Because this is already placed. Okay, this is already placed. You need to increment the I value, not J value, and you need to increment the K value also. Okay, you need to increment the K value also. 0, 1, 2, 3, 4, 5, 6, and 7. Like, okay. Yeah, now J value remains at the 4th position, not at, okay, changed. Okay. Here you need to what increment the I value. Okay. You need to increment the I value. Whenever this condition is true, A of I is less than or is equal to A of J. Okay. Yeah. Next, A of I. A of I is 12 now. Is less than or is equal to A of J 70. Now this time also condition is true. Okay. Now you need to place first subarray element into the B of J. Means 12 you need to place. And you should increment I value as well, K value. Increment K value. Okay. Increment K value. Now, okay, do the same. I is less than or is equal to A of I less than or is equal to A of J. Now the condition is false. Why? Because A of I is 25 is less than or is equal to 7. This is what false. In this case, else, what you need to do? Here condition is false. In this case, what you need to do? Okay. So else, what you need to do? Now you need to place B of K is equal to A of J. Means the second subarray element you need to put in the what? You need to put in the what? Resultant array. Okay. So now you need to place 17 here and you need to increment the K value as well J value. Now position of the J is changed. Okay, position of J is changed. So every time you need to increment the K value. Okay, irrespective of this condition is true or false. If condition is true, okay, so this part of code is executed. If condition is false, this part of condition is executed. But every time K value should be implemented. But every time I and J values are not implemented. Based depends upon the condition. Okay, depend on the what a condition. So this I and J values will be included. Okay. Now where is I? Here. Okay. Now perform the same operation. Now A of I is 25 and A of J is 32. Okay. 25, 32. Now 25 is less than or is equal to 32. So now place 25 here. Okay. So why? Because this is the lowest element now in comparison. Now which value incremented? I value incremented and K value also incremented. Now A of J. Okay. So A of J. So here A of J is 31. Right. A of J is 31. Sorry, A of I is 31 and A of J is 32. Here also condition is true. So now place what first subarray element into the resultant array. Okay, 31. Okay. Now what incremented? I value is incremented. Right. I value is incremented. Means here I value is exceed. Okay. So I value is exceed what mid value. Okay. Here I is greater than mid value. So whenever I crosses mid value, this means, okay, what it indicates is values remains in the second subarray. Okay, values remains in the second subarray. See here, I value crosses the mid value. See, after placing 31 into this, so I value is incremented now. So now I value is crosses what mid value. What it indicates is, okay, so you have what you have elements remain in the second subarray. In second subarray. Okay, second subarray. Okay, for suppose this condition is false. Okay, this condition is false. Means elements remains in the first subarray. Elements remains in the first subarray. Okay. So here, if this condition is true, what we need to do? Okay, what we need to do? Until J reaches upper bound. Until J reaches upper bound, we need to place all elements from second subarray into resultant array B of K. Okay, B of K. Now up to 31, you have placed elements here. Now, right. Now this condition won't work. Why? Because here what happened? So I crosses what mid value. I crosses mid value. So now whenever I crosses mid value, okay, whenever I crosses mid value, if I crosses mid value, what it indicates? Okay, elements remain in the second subarray. Elements remain in the second subarray. Means you need to copy all elements from second subarray to resultant array. Okay. So here while what I am doing is while j is less than or is equal to high, j is less than or is equal to high, you need to place b of k is equal to okay a of j, a of j, and you need to increment the k value and you need to increment the j value. Okay, you need to implement the j value. Okay, now I crosses mid value, right? I crosses mid value. Now this part of code will be executed. Now j less than or is equal to high. Now j, where is j? Here j is there. Okay, fine. And high value is 7, upper bound is 7. No, so now I j is at what a fifth position. Okay, now 5 is less than or is equal to 7. So what we need to do? V of k is equal to a of j. Okay, a of j means 32 placed here, and increment k value and increment j value. Okay, so increment k value and increment j value. Now j came to here. Now j position is 6. Okay, now 6 is less than or is equal to upper bound to 7. Okay, 6 less than or equal to 7. No. Now b of k is equal to a of j. Okay, now 40 placed here. Increment k value and increment j value. Now j value is 7. 7 less than or is equal to 7. Right. This condition is true. Okay, 7 less than or is equal to 7. Less than or is equal to 7. Now b of k is equal to a of j. Okay, means 42 placed here. Now increment k value and increment j value. Okay, j value is incremented, means j value comes 8. Now 8 less than or is equal to 7. Okay, this is false. So loop gets terminated. Now finally, okay, this is the started array. 8, 12, 17, 25, 31, 32, 40, 40. like this. Okay. For suppose here elements remain in the what elements remain in the what first subarray. What you need to write? You need to write reverse code of this. Okay. So if I crosses mid value means elements remain in the second subarray. Okay. Second subarray elements. Okay. Remain. Okay. Remain. If this condition is false, means first subarray elements remain. Then you need to place all elements from first subarray to resultant array. So while I is less than or is equal to mid. Okay, why? Because first subarray upper bound is mid. Okay, now you need to place all elements. Okay, into resultant array b of k is equal to a of I, a of I, and increment I value and increment j value. That's so that is the code I have written. See, this is the merge sort code. So here until this condition is what false. So I'm going to performing what divide operation on all subarrays. All subarrays means your subarray should contain only one element at last. Until you should what perform the merge sort operation. Or sorry, you need to perform the divide operation what recursively by using this merge sort function. You can also write this function name as divide also. Just I have given as automatic. So this is to perform what divide operation and in merge operation. See here, okay. So I is the what lower bound. So this is first subarray starting position. First subarray starting index, and J is the second subarray starting position. Second subarray starting position. Position. And here K is the what? Merged array or resultant array. Okay, merged array starting position. Okay, see. So this is the code which I have written during my explanation. So up to this condition is false. Okay, this condition is true. Up to this condition is true. Okay, so here I'm going to compare first subarray and the second subarray elements. If first subarray element is less than or is equal to second subarray, then I'm adding elements from okay. Whenever this condition is true, I'm adding element okay into merged array from first subarray. If this condition is false, I'm adding what? I'm adding element from second subarray to resultant array. That's it. Okay. Whenever I crosses mid value. Okay, this indicates that okay, second subarray, okay, elements remain in the second subarray. Okay, so elements are where yeah, elements remain in the second subarray. Then you need to copy all elements from second subarray to what merged array. Okay, up to what upper bound. Up to upper bound. If this condition is false, if you have elements, if this condition is false means okay, elements remain in first subarray. Elements remain in first subarray. First subarray. Okay. So now from first subarray, all elements I am adding to the what merged array or resultant array until okay. So it reaches to the mid value. Why? Because here upper bound to the first subarray is mid position. That's it. So this is the what merge sort. Okay. So I hope this is clear for everyone. Okay. Yeah. Thanks for watching. So, yeah, please subscribe.